This is a video lecture for Math 140. This is part 2 of the video lecture for Thursday, April 16th, and the topic is the law of sines. What we're doing in part 2 is we're going to solve two different practical or example problems so you guys can see how to use the law of sines to apply it to triangles. The first practice problem we're going to do is consider this triangle. Okay, this is our first practice problem. We have this given triangle. By the way, a little disclaimer, I'm just doing these drawings by hand, and so the sides the answers we come up with, the sides may not be exactly proportional to the answers I get, in the sense that the diagram may not be exactly representative of the side lengths and angles. Okay, it should be approximately, just because I'm drawing with hands, so just keep that in mind. Okay, this is the first triangle we're going to solve. First question is, what type of triangle is this? Well, here we know a side, an angle, and an angle. So this is an A, or you could think of it as angle, angle, side. This is an AS triangle, okay? And so therefore we can use the law of sines to solve this triangle. First step here is to label things. And so let me label it so it's fits with the diagram I have here so I don't get mixed up letters. I'm going to label this angle A. I'm going to label this angle C and this angle B, okay? That's up to you. You know, which angles you label A, B, and C, that can change depending on the person. But you need to be consistent. So since this is angle A, this is side length A. This is angle B, this is side length B. And this is angle C, so this is side length C. And now we're going to apply the law of sines to solve this problem. The first thing I would do here is, before applying the law of sines, I would determine this angle right here. And actually, we can determine this angle quickly because the angles of a triangle add up to 180. So, angle A equals 180 minus 102 minus 33 degrees. Okay, and what is that going to come out to? That's going to come out to 78, 75, 45 degrees. Okay, so now I know this angle is 45 degrees. And that's helpful to know. Now I know all my angles. I need to find the side lengths A and C. Now I'm going to use the law of sines, and you can pick your favorite side. Let's take side A, for instance. I could write sine of angle A, which is 45 degrees, okay, divided by side length A. And now for the other side, we want to pick an angle and side combination where we know both of these things. So I'm going to pick this combination equals sine of angle B, so sine of 102 degrees, divided by side length B, which is 19. Okay, that's important because if I decided to use this pair and say, okay, this is sine of 33 over C, then I would have two unknowns in my equation. I couldn't solve it. So here I have one unknown, but then I know this angle-side combination. So I get this equation. And now I want to solve this equation for A. There's various ways you can do this. I'll cross multiply in this case. So cross multiply means you multiply across. So this leads me to A sine of 102 degrees equals 19 times sine of 45 degrees. Okay. The final step here would be to divide both sides by sine of 102. Sine of 102. And this leads me to isolate A. A equals 19 times sine of 45 degrees divided by sine of 102. Okay? And now I can plug this in my calculator. And if I do that, I will get side length A equals 13.7. So now I've got side length A. I want to find side length C though, and I can use law of sines again. So now I'm going to write, and I'm going to show you guys something else, a way that might save us a little time. Instead of using this version of the law of sines, I'm going to flip everything over. So I can also write the law of sines, the side length C, over the sine of the angle C. Angle C is 33 degrees, okay? C over sine of 33 degrees. Now pick your other favorite pair. Now we actually have both other pairs we know. So I'm going to pick B equals side length B, which is 19, over sine of 102 degrees, okay? To solve this equation, we multiply both sides by sine of 33. So this leaves us with C equals 19 times sine of 33 degrees divided by sine of 102 degrees. Okay, and this all equals, if you guys plug this in your calculator, where did I put my my solution set here? Oh, here it is. This comes out to 10.5. Okay, this equals 10.5. So these are my answers. C is 10.5, A is 13.7, angle A is 45 degrees. And now I've solved this triangle because I've found all three sides and all three angles. Okay. Sometimes it's a good idea to think about if your answers are reasonable. Just looking at this triangle, if you look at this triangle, it's pretty obvious that side length B should be longer than either A or C, and that actually is borne out here. So this, just kind of checking the reasonableness of our answers, these seem like reasonable answers because A and C are less than B. Let's do another example of the law of sines. Okay, our second example will involve this triangle. And in this triangle, we know that this side length is 12. We know this angle is 18 degrees. And we know this angle is 107 degrees. This is angle 18 degrees. Okay. Now, what type of triangle are we dealing with here? Well, here we know an angle, a side, and an angle where the side is sandwiched between the angles. So this is an ASA triangle, which means we can use the law of sines. The first step here again is to label our triangle. To be consistent with my solutions, I labeled it this way. Again, that's up to you which letters you put where, as long as you're consistent. Okay, so I'm going to label it this way: angle A, B, and C. And this means that this is side length B, this is side length C, and this 12 is side length A, because the side lengths are always opposite to the angles. Okay. First step here again, since we know two angles, the first step is let's find angle A. Angle A will equal 180 minus the other two angles, because the angles of a triangle add to 180. And what does this equal? This equals, let's see, 107, 73. This equals 55 degrees. So now we know that angle A is 55 degrees. Okay? And now we can use the law of sines to try to solve for the other two sides of our triangle. I'm going to use the inverted version of the law of sines. You can use this version totally fine. You can also flip it over. So let's solve for angle B, side length B. That means B over sine of angle B, which is 107, equals, let's see. Now the pair we actually know, the angle side pair we know is A, equals side length A, which is 12, over the sine of angle A, which is 55 degrees. Okay. To solve this, we can multiply by sine of 107. So this means B equals 12 times sine of 107 divided by sine of 55 degrees. And if we plug this all in the mix and we calculate this, we get side length B equals 14.0. And now all we need to do is solve for side length C. And to do that, we again use the law of sines. So I'm going to write C divided by sine of angle C, which is 18 degrees, equals the side length A, which is 12, divided by the sine of 55 degrees, the sine of A, which is 55. To solve this, we multiply by sine of 18 degrees. We get C equals 12 times sine of 18 degrees divided by sine of 55 degrees. And if you guys plug this in your calculator, you will get 4.53. Okay, let's see if this makes sense to us. it looks like, based on this diagram, the angles, it looks like side length B should be the longest, and that makes sense. Side length B is a little bit longer than side length A. Side length C should be less than B. It looks like it's less than A, which is indeed true. This probably isn't quite accurate because C is actually, in actuality, C is a little bit shorter than what it looks like here, but that's just due to imperfections in this diagram. And anyway, this is our answer, and we've now solved this triangle. So we've solved an AAS and an ASA type triangle using the law of sines. This concludes the video lecture for Thursday, April 16th. I'll see you guys on Thursday.